Hi, I'm Bianca Coker and I'm a math consultant here at Region 10. In this video, we're going to look at one of our new math standards, 6.3a. This is one of the new standards in the Numbers and Operations strand. The standard states that the student applies mathematical process standards to represent addition, subtraction, multiplication, and division while solving problems and justifying solutions. The student is expected to recognize that dividing by a rational number and multiplying by its reciprocal results in equivalent values. All right, so let's look first at dividing by a fraction and look at some examples. This image represents 1/2 divided by 1/8. If you can tell, the fraction strip has been divided into half, and that part's been shaded. And then we divided that half into eighths. Well, actually, we divided the whole thing. But the part that's shaded, we're looking for exactly how many eighths there are in 1/2. Does that make sense? We're trying to find the number of eighths in the 1/2 part of the bar, and we'll see that there are 4 of them. In the next example, we see fraction circles, and what we're looking at is another half, but this one's being divided by 6. So what we have to do is take our half of a fraction circle and segment it or divide it into 6 and see how many 1/6 there are in 1/2. And of course the answer is 3. Now let's look at these two examples together. We'll have 1/2 divided by 1/8 is equal to 4, and 1/2 divided by 1/6 equals 3. This is the symbolic representation of what those concrete models were representing. And I'm asking, do you see a pattern between the way the symbols are arranged and our answers? Maybe you do, maybe you don't. Now, most people don't see a pattern after just 2, so let's look at one more. In this problem, we have 4/3, so we have one that's divided into thirds and another third added on to it, so 4/3 divided by 2/3. So the question is, how many 2/3 are there in 4/3? So this circle is circling one of the 2/3, and the next circle is encircling the other 2/3. So in 4/3 we have 2 2/3. All right, so there's the first one and there's the second one. So what we have in our pattern is we have 1/2 divided by 1/8 is 4, and we had 1/2 divided by 1/6 is 3, and to give a little bit variety, we had 4/3 divided by 2/3 is 2. So when we look at these examples, we might start noticing some relationships between our numbers, and hopefully you already know what's happening. But if we rearrange our values, we're going to have a relationship that will show us our answer, and it might be a little easier to do. So in this, when these came up, they showed a relationship with multiplication. And what we did was we said 1/2, instead of divided by 1/8, we said times the reciprocal 8/1. And when we see that multiplication, we get the same answer, which is 4. 1/2 divided by 1/6 is equal to 3, but 1/2 times the reciprocal 6/1 is also 3. And then that 4/3 divided by 2/3, which is equal to 2, but 4/3 times 3/2 is also equal to 2. So looking at many examples and many patterns, using that inductive reasoning that we want our students to use, and you probably want to do more than 3 with your students, we can come up with something like this conjecture. When we divide a fraction, we get the same answer as when we multiply by its reciprocal. Now this isn't technical math language, it's more of a verbal statement or a conjecture we might want to check out. And if we wanted to write it mathematically, we could write something like this. Any number divided by the fraction a over b is equal to that number times b over a. And of course we want to make sure that we're never dividing by 0, that we don't have fractions with 0 as our denominator. So if we can say this, if this is really true, then we never have to divide by fractions again. All we have to do is multiply by reciprocals, which can be a lot easier. So that's really why we want to do this. We want our students to know that when we change our division to a multiplication, it makes our life much easier, which is what math is all about, making our life easier. So what does this mean? Well, when justifying solutions, students need to be able to convert division by a fraction to the equivalent statement for multiplication by its reciprocal. And that will help them make sense of some of the problems they're doing and justify their reasoning. Remember, justification is not just first I did this and then I did this and then I did that. That's explanation. Justification is giving us a reason to believe in them. If they can use pictorial models, great. If they can use some of these properties that we've discovered and proven in a nice soft way, then that's wonderful too. Thank you and have a great day.